Hello friends, welcome to this video. In this video, we are going to learn how to extract images and masks from a video segmentation dataset using the OpenCV library and the Python programming language. So to learn more about it, make sure that you watch the complete video and subscribe the channel. Do check out the membership. Now without any further delay, let's start the video. So first of all, we'll start by taking a look at the dataset. So this is a website called GRIP. So it's basically Image Processing Research Group. So here they provide a video segmentation dataset for forged videos, okay, and it contains 10 zip files and other text files. So I've downloaded this complete file, and here you can see in this folder the GRIP forged video dataset. It has basically 10 folder which I have extracted, and each contains some videos. Okay, so these 10 folder are basically representing 10 different objects. First folder is basically tank, then a man, then a cat, and rest other objects. So first of all, we're going to look at this tank folder, and here it contains 4 videos. First it is called force.avi. So here you can take a look at this video. Basically video without the sound. Here you can see it has a tank, and which look like this is the forged object. Second video is basically forged video, but a compressed version of the original forged video. Third one is the mask, which basically shows a binary mask of the forged object in the video. And the last, which is the original.avi, is basically the original video where the forged object is placed. Okay, so we're going to use 2 videos. First is this forged AVI, that is original forged video. We are not going to use this compressed one. And second is this mask AVI. So we're going to extract frame from these videos. Okay, first we're going to save in an image folder, second we're going to save in a mask folder. So that's all about this complete data set. Okay, now we'll start writing the code for this. Okay, so first of all, we are going to import all the required libraries. First is the operating system libraries, second is NumPy. Third, to read the images and write them back, we're going to use OpenCV. Next is the globe. Globe is basically used to extract the images path. Okay, not the images path, the video path basically. Next is the TQDM. So TQDM basically is used as a progress bar. Just like we are looping over some things and they are really large, so we know see how much work is done and how much the work is left. So that's why we use this TQDM. Now we'll move to our main loop. So first of all, we need the path for the data set. Okay, so I'm gonna copy it from file. So you can see this is the path for the complete data set. Okay, now we need to extract 2 videos basically from this folder. So you can see there are 10 folders. Okay, and inside each folder we need to extract the force.avi and the mask.avi, and within each folder the naming remains the same, and that's a really fantastic thing because this helps us in easily automating the thing over each folder. So we don't have to write the code for each folder, we just write it in respect of the one folder, and it will remain same for the next other 9 folder. So you're gonna say video input. So input is basically the forged video. So we're gonna say globe, and inside globe we're gonna provide path. So first is the dataset path. Second we're gonna say star. Star basically represent all these 10 folders. Okay, so we're gonna go inside this 10 folder and we're gonna say force.avi. So if there's any folder, go inside it and check this force.avi. Okay, next is for the video output. We're gonna copy this. It's actually going to remain the same, just the difference is that instead of force we have mask. Okay, so now we have both the force images, the force video, and the mask video. Okay, now we're going to loop over them. So we're going to say for, let's say x comma y in zip. So within zip we're gonna say video input and video output. Okay, so let's apply TQDMA. Let's apply this later. First we're gonna take a look at this x and y. So we're gonna print x and y. So one thing is that it is really important that, like, if we got the video, the force video for the tank folder, then the mask video should also from the tank folder. It should not be like from the cat folder. It would not match correctly. So we would run this code and check whether they are correct or not. Okay, so you can see first these are basically paths. So first force videos from tank, then if we continue with this path, they can see 01 tank, then mask AVI. Okay, so let's do one thing. We're gonna extract these names x. Okay, so we're gonna say x name equals to x dot split. We're gonna use slash because these paths basically contain slashes, and we're gonna again say y name equals to y dot split. Let's put a break here because we want to see this effect for only one path. Okay, it should be x name, not x, and it should be y name. Now we're going to see a list, not a single list but two lists. Okay, so this name is basically the second last item on the list, and same for that. You can see it's basically same x tank. For the x it's 01 underscore tank, and same for the mask. We can also do one thing. We can apply sorted function here to just sort this list in a sequential order. So it would really help us to get the same image, same videos. Okay, so we're gonna say -2 here. Okay, you can see these both are same, and if these both are same, this means that the sorting is properly done. We are receiving appropriate path. So you can see it's basically same for these 10 videos. Okay, so we also need to save the data. So what we're gonna do, we're gonna read these videos, extract frames from them, and we also need to save them. So for that we need a directory. So we're gonna create a folder, not a folder, a function which would create a folder. We're gonna create a function called create dir. It would take the path as the argument, and it would check if this path exists or not. If not, if this path does not exist, then it should create this path. Okay, so now let's create a folder to save the data. Let's call it data. Okay, now we're going to run it again. Okay, you can see a folder called data is created. Now within this data folder, we're gonna create a folder with a name like tank. First we're gonna be tank, then man, and within inside this folder. Okay, so with inside this data folder we have 10 subfolder, and within each of those folder we're gonna have a two folder called image and mask. Okay, so we're gonna do them automatically program using programming. They should not be created manually. Okay, so we're gonna create two directories, two folder. We're gonna say, let's say F. So it is first is data, then the name, x name. We're gonna say imag image. Now we're gonna use the same and create another folder called mask. We're gonna run this, check it. You can see we have the data folder. So here we have all the 10 folder, and within each folder we're gonna have image and mask. Like this we're gonna have with this main folder image and mask. Okay, so the folder system is done. Now we will start reading the videos. Basically we would capture these videos and try to read frames from them. So we're gonna say x cap. X basically represents the input. Okay, we're gonna say cv2 dot capture, video capture. We're gonna provide the path x. Next we're gonna say y cap, cv2 dot video capture. We're going to say y. Okay. Now we're going to loop over these video capture. So we're going to say while true. So it would run infinitely. Okay, this w should be small. That's my mistake. Now it start reading. We're going to say x cap dot read. So we're going to read it, and it would return two things. First is a value. We're going to call it x ret, and then a frame. X read basically represent whether we have read all the frame or not. If we have read, it would return false, and this frame would be empty. And we're going to do same with the, let's say, y read and y frame for the y cap. So now we also need to break the loop. We cannot run it infinitely. So we have a condition. So if we have completely read all the frames, so we're going to say x ret is equals to false, or y ret equals to false. So if any of them is false, then break the loop. Okay, so we have the formula. Now the formula, we have break the loop, okay, successfully, because it cannot be run infinitely, otherwise the resources would be exhausted. Now we're going to print the shape for the x frame and y frame. Okay, this is basically the value. We need to print the shape of the frame. We need to check what is the shape, whether both the x and y have same shape or not. So you can see they basically have same shape, and we are reading both of them as an RGB image, basically 3-channel image. So we're going to save this image in the RGB format, but this mask would be in a grayscale format. Okay, so we're going to reprogram, or we cannot call it reprogram. We're going to change this scale, color scale accordingly from RGB to grayscale. Okay, now we're going to do something with this try statement to capture if there's any issue. So x frame is there, it's okay, we would save it. But for the y frame, we're going to say cv2 dot cvt color. Oh, should be small. Now we're going to say y frame and cv2 dot color from RGB to gray. Okay, then we're going to normalize its pixel by dividing it with 255. We want to be sure that the mask which is saved only contain two values, either 0 or 1, not any value between 0 and 1. Okay, so that's why we divided by 255. Now now the value of the pixel are in the range of 0 and 1. Then we're going to apply threshold. .5. So now these values would be converted into 0 and 1. Okay, basically boolean values. Now we're going to convert them to integer 32. So now these values are in the range of 0 and 1. So I'm going to show you with the help of this function np.unique. So this np.unique function take this array y frame, and it will only show the unique values. And from my prediction, it should only contain two values, 0 and 1. So we're going to check them. Okay, there is an error at line number 42. Okay, we have to close this statement. So we're going to say pass. Now it's okay. So you can see it contains 0 and 1, and initially in some frames it contains only 0, because there's no object in initial frames maybe, and then it has some object, that's why 0 and 1. Now what we're going to do, we're going to multiply this array which contains 0 and 1, or either 0 sometime or even 1 sometime, with 255. So 0 multiplied by 255 remains 0, and 1 multiplies 255 became 255. So only two values, 0 and 255, that is black and white. Okay, so now what we're gonna do, we're gonna save them. That's so simple. That, so just that simple we have to do. Say data. Okay, let me just copy this path from here instead of writing it my own. Okay, so what we're gonna do, we're gonna have a index here. You just see. Okay, this is, and then we're gonna say X frame. We're gonna copy this same. We're gonna change some values. Here we're gonna say Y frame, and here we're gonna say image. Instead of image, we're gonna have mask here. So this is all done. So I think this program is running now, but we cannot see anything. That's why we need the TQDM function here, that is a progress bar. If I show you, let me just show you. You can see a 0 image is there. Okay, we have one simple mistake, and you know what, we aren't incrementing this index value. Okay, so we need to increment it, this index. That's why we only have one image here, that is 0. It's not incrementing. And before that, let's apply the TQDM. Total is equals to video input, or we can say video output. They both are basically the same. Now let's run it. Before that, let me just remove this data folder and let it be created automatically. So you can see it's running. We have some, at least some values, some not values, a loop. Now we can go inside. You can see we have one folder called tank, inside images and mask. So you can see these images are saving. Okay, it's saving like it's nearly saved. 334 frames it has saved. You can see the first video is complete. Let me just stop it here. So it has saved 334 frames from this entire video. And if I just show you how these frames look, you will see this video entirely. Okay, you can see all these frames comprise of the entire video. And like this, we're gonna have the masks here. Let me just reload it again. You can see initially we have some frames as black, then the tank, we can see the forged object. So how clearly we can see the only two colors, the black and white, none of the other colors there. Okay, you can see. Now we also, you can see we have some masks which are black. So in case you don't want to include the mask which are black, you just want to include the mask which have white color in it. Okay, we can also do that easily. So let's do that now and make appropriate changes before saving. So what we know, we want to save the mask which contain white pixel, basically pixel which contain value 255. So we're going to say if 255 not in np.unique y frame. So if this list np.unique given this y frame does not contain value 255, then it should not save the mask. Okay, else if it contain, it should save the mask. So that's so easy to do. Now we're gonna run it again. So we're gonna wait. Okay. Now you can see it's saving the frames, but you can see the starting is not with the 0, is with 3, and we hope the ending would not be like 334. Okay, so for the first video is done, and it has taken like 16, or we can say the 21 second. It has taken 20 seconds to process one video, and same for the mask. Now it only contain the images and mask which contain even a little portion of the forged object. So we basically check if it contain any white pixel. Is that? So you can see now it will only contain the forged object. It does not contain any blank mask. Okay, so that's how you will process rest of the videos also. Let me remove this folder, and we're going to run this entire program again, and it will take a time. So till then I just pause the video, and when the processing is complete I will unpause the video. The processing of all the videos are completed, and it have taken 4 minutes and 51 seconds. So you can see it has taken nearly 5 minutes, and you can see in between we have some error, and that's why it's better to use a try except statement to capture these, so that your program does not stop in between. And if you look at the data, we have all the 10 folders, and within, okay, we have these images, we have the mask, and that's for the man folder, that's for the cat folder, that's for the helicopter. So you can see we have successfully extracted images and mask from the video segmentation dataset. Now you can easily use them in any segmentation architecture, okay, and try to segment. So with this dataset you can easily create a segmentation, a forgery segmentation problem. Okay, so this video dataset is basically for forgery detection. Now you can use this code, extract images and mask from these videos, and create an architecture to detect or segment the forgery. Okay, so I hope I was able to give you some new information from this video, and if I really did, then please like the video, subscribe the channel, and do check out the membership. By taking membership you not only help me in my research, but in return you will get new content. Thank you, have a nice day.